Hi, welcome to another EC&M Tech Talk. Conduits. Where do we find the information on these circular raceways? Which ones do we use, where and when, and so forth? And importantly, how do we size these raceways based on the number of conductors or cables that we want to put on the inside of them? So anyway, that's how we're going to start. Where do I find the info? Then we'll move into what types of conduits apply where, and then we'll see how we size them. So the first thing is, where do we find this information? Well, for me, what I do is I go to, of course, my NEC, right? National Electrical Code. I'm using the 2026, so my references for this Tech Talk will be from the 2026 NEC. And the first thing I do is I go to the table of contents. So let me show you how I mark up my table of contents. So maybe you might want to do the same thing, help you find the information. I'm on page 3 of the 2026 NEC, and it is the table of contents, and it's these circular raceways, we're going to see them defined, are what you and I call conduits and tubing. They start with Article 342. So I have marked on the right-hand column on page 3, I have highlighted everything, Articles 342, 344, 348, and so on, all the way up through Article 362. And then I have that red line drawn to the next, and I label them conduits. And that way I can easily find them in my table of contents, because I don't remember all these article numbers. You know, what's RTRC? What article is that? Oh, I don't know, but I know I can go to page 3 real quick and look and see, oh, that's Article 355. And of course, again, it gives me the page number. Also notice that each one of these conduits is divided up into 3 parts. Part 1 is general information, part 2 is installation requirements, and part 3 will be construction specifications. So I'm going to go through and show you here in just a bit on how to easily find that information as we move on through. Now, first of all, we're going to look in Article 100. If we look in Article 100, we're going to find the definitions for these different types of conduits and tubing, really, that we're talking about. So we look under conduit, comma, and the first one we probably run across is, let's see, alphabetically, it may be flexible metal conduit, right? FMC. So we're first going to go through and I'll talk about some of these flexible conduits, and we'll move into the other types, the rigid types of conduits as well. So anyway, if I look at these definitions, pretty much the same, but a little bit different, obviously. For instance, flexible metal conduit, helically wound, formed, interlocked metal strips. Okay, flex, right? Flexible metal conduit. Conduit, high density polyethylene, HDPE. It tells us it's a non-metallic raceway, and it's typically used, in direction. It doesn't really give us all this in the definitions. But where do we find this HDPE? Well, typically used for directional boring, like you see in the image there. We use it a lot for communication wiring. You see it installed today. Liquid tight flexible metal conduit, LFMC. Well, it has an outer jacket on it that's liquid tight. It's non-metallic, sunlight resistant jacket over this inner flexible metal core. That's our definition for LFMC. Now, when it comes to liquid tight flexible non-metallic conduit, there are 3 types. Let's take a look at one. So this tells me this is, where is it? Oh gosh, it's on here somewhere, LFNC-B. So there are 3 types of this liquid tight flexible non-metallic conduit. And type A, the 3 types, A, B, and C is what it is. And the 3 types are talking about the support for on the inside when they construct the conduit. Okay, so LFNCA has 1 or more reinforcement layers between the core and the outer covering. LFNCB, which this is, has an integral reinforcement within the raceway wall. And then LFNCC, which can also just be abbreviated LFNC, according to the informational note there, it says there's no reinforcement at all. Well, I normally wouldn't look at it and tell you what type of reinforcement, thing like that. I can't tell. But you just look on the labeling. Of course, required to be there. It's required to be marked. And it'll let you know what it is. Now, we haven't looked yet at where we can use these different types of conduits. Then we have rigid metal conduit. RMC, rigid metal conduit. And that's Article 344. But let's take a look. Let's see what we've got. Here's some rigid metal conduit. So my rigid metal conduit, galvanized rigid metal, and it's smooth on the inside. So it's made for pulling conductors through it. It's got tapered threads on it, 3/4 inch per foot. It's going to tell us that in the particular article. In this case, my coupling has straight threads. So we're going to see in Article 344, one of the important things with rigid is that I make it up wrench tight. If I've got tapered threads here and straight threads in this coupling, if I put this coupling on and just take a few threads on it, it's pretty loose. Well, we're going to find out we can use, that's not good. Well, one, it's not mechanically secure, but we're going to find out we can use this rigid metal conduit as our equipment grounding conductor. So if I'm using this to carry fault current back to the source, the metal conduit, and I've got a loose fitting like that, I've got big trouble, don't I? I've got a high impedance point, resistance, heat being produced, not carrying enough fault current back to the source, maybe to clear the fault and things like that. So I have to make up my conduits, all of my conduits, I have to make them up in accordance with their NEC article, as well as Article 300. We'll talk a little bit at the end of the presentation. We'll talk a little bit about it. So anyway, rigid metal conduit, we certainly use a lot of that in all types of locations, don't we? Intermediate metal conduit, very similar to rigid metal conduit. Articles are very similar to each other. The difference is the intermediate metal conduit is going to have a little bit thinner wall than what the rigid metal conduit has. But it's still a threadable type raceway, and same information on threading and so forth we'll find in the articles on it. Then we have rigid polyvinyl chloride, PVC conduit, right? It's rigid, it's non-metallic, and I can get this, here's a factory bent elbow, right? But this tells me it's, lots of information on here, okay? But it tells me, let's see, Schedule 80. So Schedule 80, the difference between the Schedule 80 is a heavier wall conduit. Same outside dimensions, so my same fittings will fit on the Schedule 40 or the Schedule 80, but the Schedule 80 has a thicker wall. So it tells me in the article on PVC conduit, hey, if I'm going to use this to protect conductors from physical damage, I want to use Schedule 80, not Schedule 40 then. So rigid PVC conduit, we certainly use a lot of that, don't we? Then we have RTRC, reinforced thermal setting resin. Whoa, what is that? Well, you and I got a good name for it. We just call it fiberglass, don't we? Wow, this is really light stuff. So this is light. This is some 1-inch RTRC. It's rigid, that's for sure. And when I use this particular conduit, I have to follow the manufacturer's instructions to assemble it and put my glues and things like that in order to put it all together. But anyway, fiberglass. We use a lot of fiberglass now. I can use it outdoors, wet locations. I can direct bury it in the earth and so forth. So lots of applications for RTRC type conduit, fiberglass conduit. Non-metallic underground conduit with the conductors already on the inside of it. So it's non-metallic, it's a smooth wall raceway, and it comes with the conductors or cables on the inside of it. NUCC conduit then. And then we have our tubings. So now in Article 100, I'd have to go from conduit, comma, whatever. I'd have to go to conduit, comma, or excuse me, I'd have to go to tubing, comma, whatever. So probably the first and one of the most common, certainly, used all over, is thin wall, right? Electrical metallic tubing, type EMT. Now, if we look at some EMT conduit, here's another factory bent elbow. It is thin wall. I can thread it. I'd ruin it if I tried to, right? And so we're going to either use compression or set screw connectors on it to tie it all together. And it's a lot easier, certainly a lot easier to bend than rigid or even IMC, but it's a very strong and sturdy conduit. And you know, when I look at these definitions, when I look at all of these definitions for all of these conduits, it's going to talk about what they do is they provide protection and support for my conductors. And it also talks about I have to use the appropriate fittings with them. Well, that makes sense. We're not going to argue that one, that's for sure. So we use the appropriate type fittings and so forth. And the metal type, such as this metallic tubing or the rigid conduit, we're going to find that we can use these, since they are metal, we can use them as the equipment grounding conductor as well. Obviously, the non-metallic type, that's not going to work. We're going to have to run the wire type equipment grounding conductor on the inside. But anymore, don't we typically, in most applications today, we probably are running that equipment grounding conductor wire type on the inside of the metal conduits as well. And then we have electrical non-metallic tubing. So we just looked at electrical metallic. We have electrical non-metallic tubing. Article 100 tells me that this is non-metallic, right, by definition. It's pliable. It's a corrugated raceway, and it's resistant to moisture and chemical atmospheres, and it's flame retardant. And it can be bent by hand. That's what it means by pliable, is what it explains to me. It says without something about undue force or something, I'm able to bend this with my hand. So anyway, that's electrical non-metallic conduit. Now, we have a lot of specific requirements, as we do with all these conduits, is where we can install them and apply them and so forth. But we're going to take a look at how to find that information. And then we have flexible metallic tubing type FMT. It's flexible, just like it says. It's a metal raceway, and it's liquid tight without a non-metallic jacket on it then. So FMT, flexible metallic tubing. Another definition that we find in Article 100 is for conduit body. So, I don't know, here's a couple of conduit bodies. So the conduit body, it tells me it's separate from, by definition in Article 100, a conduit body is separate from the conduit itself, right? So I can take, and of course I can take this conduit body, this LL is what it is, and so I can take my LL off, separate from the conduit, and the key is it has a cover on it. So it has a cover, so I can pull the cover off and I can access my conductors on the inside. So that can be handy. If I have the volume marked in here, which probably is pretty typical that they do, I'm also allowed to splice inside of this conduit body. But once again, other requirements in the code and all that. So that's my definitions then that I find in Article 100 on the different types of conduits. And that's where I go to just start finding my information. Now, if we were to go through each one of these articles and try and figure out, oh man, what applies, what are the rules for each one of these conduits, we'd be here, I guess, a week or so or whatever, trying to figure all that out. But the way that these conduit and tubing articles are laid out, they're all laid out essentially the same. So if I just know what article number, if I can go to the table of contents and pull out the right article number, and I want to know where I can use this content, or where I can use this article or this conduit, right? I'll get it right. So where can I use this conduit? I pull the article number from the table of contents, and then I just look in that particular article, section .10. .10 will be uses permitted, you see. And so the way that these articles are laid out, .1 is always going to be the scope, what it applies to, the article. .2 is on the listing requirements. I'm going to find everything, and my components have to be listed when it comes to my conduits and tubing. And .3 is interesting because it talks about conditioned and reconditioned equipment. We'll take a look at that in Article 344, for example. .10, as I mentioned, is uses permitted, and .12 is specifically uses not permitted for that particular conduit. Bending radius is covered in dot 24, as well as there's a table in chapter 9. Table 2 in chapter 9 gives me my bending radius for different size conduits. Dot 30 is going to be securing and supporting of those conduits. And dot 100, which is part 3, is going to be my construction, how those usually fairly short sections on how that particular conduit or tubing is constructed. So that makes it a lot easier. We'll go through and we'll look at an example and see how that's laid out then. Let's take the example of Article 344. Article 344 is rigid metal conduit, RMC. Once again, it's divided up into 3 separate parts, Part 1, Part 2, and Part 3. So I'm going to grab my code book and let's go through and take a look at 344. For me, that starts on the 2026 code. That starts on page 276. So taking a look at page 276, let's see what we got. Whoa, that was really sharp. Conduit falling on my table over here. All right. So it starts with the scope. 344.1 is the scope, general information there, what the article applies to. Dot 2 is listing requirement. And what it tells me is it says that 344.2, RMC, factory elbows, and couplings and associated fittings shall be listed. I can look up the definition of listed in Article 100, can I? 344.3, this is a new section for all my conduit and tubing articles. 344.3 is on reconditioned equipment. Now, don't read too much into this, alrighty? Don't get too excited. It says Section A, permitted to be installed, is reserved for future use, but subsection B on 344.3 says not permitted to be installed. The installation of the following reconditioned equipment shall not be permitted: RMC, RMC factory elbows and couplings, and RMC associated fittings. What is it talking about? Well, first of all, you better look up the definition of recondition. Don't get confused. Somebody asked me, well, this means then if I've got some scrap 8-foot piece of conduit, I can go cut off the 6 feet that I need and I can't use it somewhere else now because I'm reconditioning. No. Please don't get confused. That's not what that means. If you look at the definition of recondition, it talks about I'm sending something out, typically back to the factory, in order to be refurbished and made like new. When was the last time you sent conduit back to the factory to get refurbished so that it looks just like it was when it was brand new? I don't think I ever have. Okay, I know I never have. So anyway, be aware of that. Yes, I can use a conduit out of the scrap pile if it works or whatever, as long as it's in good shape and so on and so forth. A little common sense there, I think. Right? Now, part 2, when we move into the installation requirements, uses permitted and not permitted is dot 12. So dot 10 is uses permitted. 344.10, there are 5 subsections when it comes to rigid conduit. Each one of these conduits, you're going to find some very specific information on where I can use it and where I cannot use it. Okay, so for instance, the 5 subsections when it comes to Article 344 rigid conduit, it says that I can use galvanized. Well, subsection A talks about atmospheric conditions and occupancies. It says that I can use galvanized steel, PVC coated steel, stainless steel, and red brass RMC is permitted under all atmosphere conditions and occupancies. And then it goes on. There's another subsection on corrosive environments and cinder fill, another one on wet locations, and then finally one on severe physical damage. It says I can use it where it's subject to severe physical damage. Now, I did lie to you a little bit. I said dot 12 was used as not permitted. Some of these conduits, like where I can use them in all atmospheric locations, it says, there's no reason for a dot 12. Use is not permitted. So I can use it everywhere. So for instance, for rigid and intermediate, you're not going to find a subsection or a section 344.12 or whatever, okay? Use is not permitted. here we go. 344.14 talks about dissimilar metals, and it tells me that I should always try and avoid the joining together of dissimilar metals. It gives me some specifics when it comes to rigid conduit, but I try to avoid that, it tells me, in order to prevent galvanic action. 344.20, my dot 20 section on my conduits is going to give me my minimum and maximum trade sizes for those conduits. The number of conductors is dot 22, and how many conductors can I put inside of this rigid conduit? And the answer is, it depends. Well, how do I know what it is? Well, go look in Chapter 9, Table 1. Okay, and we're going to head there in a little bit, and we'll be able to figure that out. It's going to be nice if they're all the same size. I'll just be able to use one informative annex. Now, anyway, 344.24 talks about my bends. No more than 360 degrees in the run without putting some type of box or conduit body or something where I can access those conductors. That's one I don't want to violate anyway, right, when we pull conductors. It's just getting too hard to try and pull conductors. And it tells us that not only is it going to be hard, but what? It says you don't want to damage your conductors, certainly, by having to pull on them too hard and damage the insulation, damage the conductor. Reaming and threading is dot 28. Yeah, so rigid conduit, after I go ahead and I cut and I thread my rigid conduit, it's going to be really sharp right in here, isn't it? So I'm going to have to go ahead and ream that out, and it flares it out is what it does, smooths it out. If not, I pull conductors across there, I could damage some insulation. So I want to use the proper tool in order to ream out my conduit. When it comes to threading my conduit, I want to follow my instructions. It talks in here about running threads, and 344.42, and it talks about running threads are permitted. We said these threads were tapered, right? And so if I were to go ahead and cut threads, I don't know, 2 or 3 inches up here on this nipple, my goodness, I could take this guy and I could just screw it all the way on there, huh? I haven't made up anything very tight, and that'd be ridiculous. I don't want that. So follow your instructions. There's some good NECA standards on how to thread conduit. Of course, the code doesn't give you the specifics on how to use sharp dies and how to use your dies depending on the type threader that you're using and how far back to cut the threads, and use lots and lots and lots of oil as for cutting the threads and so on and so forth. Those specifics you're going to find elsewhere, not in the code book. But anyway, you need to learn. If you're going to thread conduit, make sure that you learn how to do that properly if you're not already doing that, okay? It has to be securely fastened in place is 344.30, and there's a table. This one's 344.30b, supports for rigid metal conduit. And it tells me about it has to be, depending on the trade size, how often it has to be supported, every 10 feet or 12 feet or whatever it is, and how the distance to within a box. For instance, you can see I've got some type EMT or EMT now, we just call it conduit, thin wall conduit, and it has to be supported within 1 foot of the box. And here, this is a fairly short run of EMT between the box and the panel board. And so by putting just one support in the middle, I'm able to meet that requirement. I'm right at a little less than right at 12 inches anyway. So I'll meet that requirement for supporting within 12 inches of the box on that particular conduit. But once again, each conduit, you're going to follow those specific conduit requirements for supports. Bushings, 344.46. Where a conduit system enters a box, fitting, or other enclosure, a bushing shall be provided to protect the wires from abrasion, unless the box fitting or enclosure is designed to provide such protection. That's obviously the big issue. And we have other code requirements. We'll see requirements in that Article 300 on general wiring methods for conductors and raceways, specific requirements for bushings. Now, Part 3 then, 344.60 tells me that I can use my rigid metal conduit for my equipment grounding conductor. Obviously, that's going to depend on the type of conduit as well. And then 344.100 is my construction requirements, pretty simple, and tells me what I've already been talking about it being what types of materials it can be: steel with protective coatings, aluminum, red brass, or stainless steel. And then 344.120 is my marking requirements. Those marking requirements, what has to be on there, are spelled out in 110.21. Yeah, 110.21a, but it has to be marked every 10 feet. Well, that is just an example then of the type of information that we're going to find. It's divided up, remember, by section numbers pretty well throughout each individual conduit or tubing that you look at. You're going to find, dot 30 is going to be support requirements, dot 10 is going to be uses permitted, and so forth. So when it comes to selecting the proper type of conduit that you need to figure out, oh, this is, I got some of this fiberglass conduit. Can I put that underground? Can I just direct bury this stuff? I mean, it's fiberglass. I guess, I don't know. Well, what do? You go take a look you look up the article for RTRC type conduit, look in dot 10 and dot 12. And yeah, in dot 10, it's going to tell you I can go ahead and direct bury a fiberglass conduit and so forth. Anyway, so that's how you determine then what types of conduit you can use where. Look at dot 10 and dot 12. And of course, look at your practical application. Now, you're going to have other things to consider as well. Maybe what type of conduit I have on hand. I have to know what type of structure I'm wiring inside of, installing this wiring method. Can I go up so many floors, above ground level with E&T and so forth and so on. So all of that comes into play, not to mention cost, right, as well. Also, how long does it take me to install this conduit? Rigid, where I have to cut it and thread it and ream it and so on and so forth, and it's not easy to bend, it's going to take me longer to install than E&T or fiberglass conduit or something like that. So anyway, but if I'm in a hazardous location, hey, I got to use that type of conduit that's suitable for hazardous location then. So I need to work with dot 10 and dot 12, look at my specific applications, take a look at the other articles that are applied to the location where you're working, and then you select the best conduit for your particular application. Now, the next thing let's take a look at is how do we determine what size conduit do I need? And the answer is we have to go to Chapter 9. Chapter 9 has several tables in it we're going to be using. Chapter 9, Table 1 is going to tell us how much we can fill a raceway. In other words, this particular raceway, it has a certain cross-sectional area, doesn't it? This piece of 3/4 inch rigid. What is that? I don't know right off, but there's a table in Chapter 9 that would tell me. And I'm only allowed to fill up, for instance, if I'm going to use, say, more than 2 conductors inside the raceway, I'm only allowed to fill up 40% of that cross-sectional area with conductors. If it's just 2 conductors, I have to limit my conductor fill to 31% of that cross-sectional area. But if I'm only putting 1 conductor cable on the inside, then I'm limited to all the way up to 53% fill on my raceway, okay? So that tells me that's in Chapter 9, Table 1. It gives me those numbers. If it is a nipple, which means it's 24 inches or less, I can fill that to 60% fill. Now, how do I know that? Because when I look at Chapter 9, Table 1, it's really a very short table, but it's got almost a whole page full of notes. So you want to read the notes on that. There's lots of information. So let's talk a little bit about Chapter 9, Table 1. Note number 1, if all my conductors are the same size, and how many conductors can I put in that raceway? It says go to Informative Annex C. Table 1 applies to a complete conduit run. It doesn't apply if I'm just using a short run of raceway for some reason to give some physical protection to conductors. My fill requirements don't apply. Equipment grounding and bonding in conductors is note number 3, shall be included when calculating my conductor fill. They take up space. so I have to include them in my calculation. Where conduit or tubing or nipples not exceeding 24 inches, there's my 60% fill for nipples in note number 4. Note number 5 talks about multi-conductor cables. Note number 6, for combinations of conductors of different sizes. Oh, we're going to have to go to tables 5 and 4. I'm going to show you an example of that. So pay attention to your notes then. As always, remember, notes to a table are part of the code requirements. Informational notes are there just for information, like it says. But my notes that are actually at the bottom or after the table do apply to the code. Okay, they are code requirements. So let's take a look at an example where all my conductors are the same size, and I need to determine what size conduit do I need. In this example, let's say, I don't know. I'm going to start, by the way, on page 844 is where I find Informative Annex C, and you're going to find the table of contents for Annex C on page 844. You'll notice that there is a table for each one of the different types of conduits. In fact, there's 2 tables. There's one table for the conduits and another one if I'm using compact stranded conductors. That's the table with that's designated as A. So for instance, table C1 is for electrical metallic tubing. C1A is for electrical metallic tubing with compact stranded conductors. If you look at the 2 tables, you'll see the differences. So compact stranding conductors, that's where when we extrude those conductors, when they're manufactured, they're just all compressed together so tightly that those individual strands are squeezed together. They're no longer around. There's some odd different shapes, but they're squeezed together so tightly that the interstices, the air voids in between the individual strands, are removed. How do I know that? I go to table C1A and I look at the bottom and it tells me that. The bottom of each page will tell me what it means by compact stranding. Now, compact stranding I only use in certain larger size conductors, so you'll notice that the tables don't start, for instance, on number 14Y or whatever. It might start on something like number 8. So there's going to be different tables. Also, dimensions are slightly different for the conductors if I've compact stranded them. So be aware of that difference. Let's take an example. Let's say that I'm going to run some conductors. Maybe I've got 15 number 12 THHNs. What size conduit do I need? EMT conduit, EMT tubing then, electrical metallic tubing. So that happens to be table C1. And I look down the left-hand column and I find my different types of conductors. If I go over to page, 846, I'll find my THHN in the left-hand column. It's the second grouping down on the left-hand column. THHN, the next column over is my conductor sizes. I said we were using number 12, so I find the number 12 in that second column. And then I read over, and I said I needed 15 of them in an EMT. What size EMT? Well, I read over. Well, number 9 could go in a trade size 1/2. That wouldn't work. But it says that a trade size 3/4, I could put 16 of those number 12 THHNs in there. So that 3/4 would work for my 15 12AWG THHN conductors then. So Informative Annex C. Find a particular raceway that applies. Look at your particular conductor that you're using, the conductor size, and then read across to the right and find out which size conduit you need. So now let's do an example where my conductors are different sizes. Let's say, for example, I know I've got to use rigid metal conduit, I've determined, and so I'm going to have to first go to table 5 to find out the specifics on all these different conductors. Let's put them up on the screen and take a look. I've got 6 number 8 THWs I'm running. I have 3 number 10 THHNs and 1 number 12. Well, I need to know what's the cubic inches of all these different conductors. So I look at table 5 and I find out that number 8 THW is 0.0437 square inches, or inches square. I have 6 of them, 6 times that 0.0437. You can see the numbers, 0.2622. I've got 3 number 10s THHN. Each THHN is 0.0211 according to table 5. I've got 3 of them for a total of 0.0633. Then I only have 1 number 12. I looked that up, and number 12 THHN is 0.0133 square inches. So now I add those total of those 3 conductors up, and I come up with 0.3388 inches square. Now I've got to find a conduit then, a rigid conduit that can accommodate those 0.3388 square inches of conductor material and not exceed my conductor fill requirements on that conduit, which would be 40%. So here I can go next to table 4. Table 4 is on page 783, and table 4 is divided up by different types of raceways. So table 4 on page 783, article 344, you find rigid metal conduit. And sure enough, you take a look, and trade size 1 can accommodate up to 0.355 square inches of conductor material and not exceed 40% fill for over the 2 wires. So a little bit of practice on that one, but that's how I'm going to determine what size raceway that I need. So if all my conductors are the same size, once again, go to Informative Annex C and make life easy for yourself. If they are different sizes, as often happens many times, you're going to have to go to table 5 and add up the areas for each one of those individual or groups of conductors that you're using. Get your total area, take that to table 4, and look up for whatever particular conduit then, what size conduit that you need. So that's how we size our conduit. So we've looked at the different types of conduits. We've looked at how do we find information in the code book on applying these conduits. We've looked at information that can help to determine what types of conduits that we need. And then we looked at how to size those conduits. Finally, just briefly, the last thing I want to mention is Article 300, the general requirements for wiring methods and materials. Once I'm all ready and I'm set now, I've got my conduit and I'm ready to go install it, make sure you follow in Article 300 as well. For instance, 300.5 is on conductors. If I'm going underground, you need to take a look at 300.7 for underground installations. There's information on raceways exposed to different temperatures, raceways above ground in wet locations, specific requirements for those. Mechanical and electrical continuity. For instance, we, as part of a system, we can't pull our wires into our conduit until that conduit is completely installed in. And then finally, 300.20 is on raceway installation, but lots and lots of information. Good size article then, Article 300. So that's it on conductors and tubing. And when you go out and install all this equipment, right, make sure that you work safe.